Hello friends, welcome to my channel TutorASRumale. Kindly subscribe my channel by clicking on the subscribe button, and then don't forget to click on the bell icon so that you can get the continuous update on the new uploaded videos. Okay, I'm very thankful for all the subscribers who subscribe my channel, and welcomes all of you to my channel. Hello, I'm Dr. Aniruddha Suvarnaprabha Subhash Chandra Ramale, right now working as an associate professor and HOD at GHRCM Wagadi Pune in Computer Department. This video is about the innovative teaching learning practices that we are using at GHRCM. Actually, I'm having this my YouTube channel, TutorASRumale, and through this YouTube channel, I'm actually uploaded many videos. But one day, this came into my mind. Why not to upload the presentations recording of the students? So, what I did for machine learning, I especially have given these topics to the third year students where to the class which I am teaching this machine learning right now, and these are the topics that I have given. There are total 75 students, and ask them uh, to create the presentation, that is student must create presentation on the listed topic and record it using OBS Studio or Microsoft Expression. The recorded video must be uploaded to Google Classroom that we are having on title page of presentation. So few of the students who comply with this presentation video creation, they actually uh, uploaded this video on the Google Classroom and somehow given those videos to me directly on the pen drive. So what I decided after seeing this video to combine all those video into one video and upload them for what we call as evaluation to the world. So maybe because the videos are actually recorded by the students many times what does they create this presentation in hurry, and sometimes they may not use the proper English because some students have used Hindi and Marathi language also while explaining the machine learning. My request is to all of you that you kindly evaluate the content of each video of the student and kindly give some comments on it. Okay, your comments, whether positive or negative, okay, are always welcome. Just don't. That's what I require. And instantly, don't forget to subscribe my YouTube channel TutorASRumale. I myself are going to upload the complete tutorial on machine learning. Right now, we are very busy in MBA process of the department, so I'm not getting sufficient time to create a thorough video on machine learning. So maybe in the month of April and onwards, I will upload the entire machine learning course on TutorASRumale. Till then, I'm requesting you to subscribe my YouTube channel TutorASRumale, evaluate my students' presentation, and if there is anything wrong in presentation, anything, some small mistakes or something, kindly point out them. If there is something good in the presentation, kindly point out them. Okay, so here are the presentations given by the students. Okay, none of these presentations are actually of mine. Every presentation have the student's name, his photograph, and something like that. Okay, and all those are, I just combine this with this video. Thank you very much for visiting TutorASRumale. And once again requesting all of you to subscribe it, share it, and don't forget to click on the bell icon for new videos. Thank you. Thank you very much.
Here I am going to explain the machine learning topic, Kernel PCA. Myself Amol Mohan Nimbalkar, roll number TCOB 142, Department Computer. Here is the table content. First of all, we have seen introduction Next, some new problems, kernel trick, their principle, advantage, centric data, and conclusion. Here is the next slide of the introduction. In the field of multivariate statistics, kernel PCA component analysis means kernel PCA is an extension of principal component analysis PCA using techniques of kernel methods. Using a kernel, the original linear operation of PCA are performed in a reproducing kernel deliberate space. It is the map. KPCA is an extension of principal component analysis. It computes PCA into a new feature space dimension, useful for feature extraction, dimensionally reduction. Here are some new problems. Low input dimension, problem dependent, hard optimization problem. Here is the kernel trick. KPCA captures the overall variance of patterns. Here is the principle. We are not interested in a PC in the input space. We are interested in a PC of features that are not non-linearly related to original ones. Here is the graph. We have seen the data and features. Okay. Here we are going to learn some advantage. It is assuming a much higher dimensional space is more realistic in a real world problems. PCA as a dimensional reduction technique tries to find a low dimensional linear subsequence that the data are confined to. Here is centering data in feature spaces. It is fact very difficult to explicitly center the data in feature space, but we know that the final algorithm only depends on the kernel matrix. So if we can center the kernel matrix, here is the conclusion in the last slide. We see that the kernel categorical embedding can be improved by using a PCA instead of the Laplacian formulation. Just using PCA for a single categorical variable is very useful because it allows to map the categories into a low dimensional vector space without sacrifice linear separability.
Hello everyone, my name is Anantambat and my topic is anomaly detections, which is belongs from machine learning. In the anomaly detection, we will cover these points. The points first point is the what are anomalies. Second point is principle of anomaly detections. In the principle of anomaly detection, 2 points. The first one is classification based anomaly detection. Second one is anomaly detection model. The third point of this PPT is the advantages and the limitation of anomaly detection. Fourth point, challenges in anomaly detection. And the last point is output of anomaly detection. First one we will see what are anomalies. Anomaly is a pattern in the data that does not conform to the expected behavior. That means the pattern which is not have any confirmation what is the behavior of that pattern in after execution period. The second point is anomalies occurs very infrequently among this enormous amount of data or transaction that is generated in many scientific, commercial, and other real-life applications. It is also referred as outliers, exceptions, etc. Detection of anomalies has recently gained a lot of attention in many security domains. That means so many securities are working on anomaly detection to solve it, to prevent the anomalies in the regular data of the user. The ranging from intrusion detection to detection of fraudulent transaction in real life application. The following are the example of real life anomalies. That is, first one is credit card fraud, second is insurance claim fraud, and mobile or cell phone fraud, etc. Anomalies as outliers. We already saw in the second PPT, second slide of our PPT. Anomalies is also exceptions or outliers. Although anomalies are or outliers occur very infrequently and their impact is quite high compared to other events, making the detection extremely important. Anomalies is dangerous for our data because it infrequently occur in our data That's why user never have any idea or doesn't have any idea about that anomalies that we must have to detect that data and remove from our data. In this example, we try to show the anomalies as outliers. In this diagram, you can show N1 and N2 are regions of a normal behavior. This is N1 region, this is N2 regions. In the N1 regions, N2 regions are the normal behavior of data, but you can see here O1 and O2. These are the anomalies which is infrequently occurred in our data. Anomaly detection. Assumption. Assumption intrusion are necessarily abnormal in terms of use behavior of or system behavior. We must have to focus on finding and defining what is a normal user or system or network behavior. The third point is build some model to represent the normal behavior. Alert is raised if the current user or system behavior deviates substantially from normal behavior. Next point is classification based anomaly detection, which is belongs in the principles of anomaly detection. Classification is used to train a model from a set of labeled data instances and then classify a test instance into one of the classes normal or anomalies using the learned model, that is testing. That means we are train a first model. Means classification is used to train a model, which is first train the model and its labeling of the data, means set the labeling of data and then test it in a normal form. An anomaly detection approach roughly consists of two phases. One is training phase and testing. The first one is training phase. In the training phase, an anomaly detection system first creates a profile of the normal system or network or program activity. It first creates profile like any network or any like we can take a real life example as our websites. First we create a profile of data that same like Salesforce anomaly detection system first creates a profile of normal system network or program. Because of that we can accept the train data or we can also train the data as per the user requirement. The second one is testing phase. Learn profile is applied to new data. We already profile creates, we train that profile, that means that profile become a learn, that profile knows actually what's the working of anomaly detection. That learn profile is applied to your new data. It is any activity that deviates from the profile treated as a possible intrusion. A test instance is classified as a normal or anomalous using the classifier we already discussed in this first point of our classification based anomaly detection. The second point of the principle-based anomaly detection is the anomaly detection model. A typically anomaly detection model is illustrated in following figure. You can see here is the system profile, which is created in the classification. Actually, we saw in the last slide. It generates a new profile, or if any data have a existing profile, that it can be modified. It's also provide timing information. That created profile is run to the anomaly detection. That anomaly detection significantly deviant. Deviant means already say we train that data. Actually, that data is learn. That data then become a learned data. After learned data, we apply that the learned data to the set. That is the data collection set. We applied that learned data to the data collection set, and we generate a response. Now we see in brief in next slide. In this, anomaly detection models working. That means it consists of four components: data collection, system profile, anomaly detection, and last is response. Normal user activities or traffic data are obtained and saved by the data collection components. That is the data. Specific modeling techniques are used to create normal profile. To anomaly detection components decide how far the current activity deviates from the normal system profiles and accordingly what percentage of these activities should be flagged as abnormal. Finally, the response component report the intrusions and sometimes corresponding timing information. The advantages of anomaly detection. The first advantage of anomaly detection is anomaly detection systems offer several benefits. The primary advantage of anomaly detection is has the potential to detect a novel attack or previously unknown attacks, which is it's also can potential to detect a novel attacks and previously unknown attacks. That is for example uh, so many attacks like ransomware attacks. This is also one type of anomaly detection. Anomaly detection system addresses the biggest limitation of misuse detection system. The biggest limitation of misuse detection system, which that means the misuse of a user system is is not happen because of the anomaly detection. Anomaly detection prevent the unknown source or unknown user or any unknown network to misuse the actual user, the actual owner of that data. A second advantage of anomaly detection system is that profile of a normal activity are customized for every system or application and network. That means the profile of a normal activity are customized for every system. That means profile is not the same for every system. Suppose one profile is have only reading reading authority to one PC number one, to PC number two has on another activities or another allows like a reading, writing, or editing. That's same like in every system or every application or network have a customized profile for a normal activity. This makes very difficult for an attacker to know with certainty what activity it can carry out without getting detected. Anomaly detection systems have the capability to detect a zero-day attack as well as insider attack. That means anomaly detection system have the capability detects zero-day attacks as well as insider attack. That means it prevents possibly every attacks, prevent to every attacks possibly as well as insider attack also. Disadvantages of anomaly detection. Due to the underlying assumption of anomaly detection mechanisms, their false alarm rates are in general very high compared to misuse detection system. False alarm rates are very high. That means sometimes it prevents unnecessary data also. Some data is supposed necessary and user have that user want that data. That time anomaly detection prevent that data. This is also one of the disadvantage of anomaly detection. The main reason for this limitation includes the following. The user's normal behavior model is based on data collected over a period of time. The effectiveness of anomaly detection is heavily dependent on how accuracy the normal behavior is modeled and updated over time. Any mistake in choosing the parameters or features used for building the normal profile will increase the false alarm rate and decrease the effectiveness of the anomaly detection system. That means sometimes it it does the mistake to choose the parameter or features to build the normal profile, which is also increase the false alarm rate or decrease the effectiveness of the anomaly detection system. Usually more computationally expensive than misuse detections. It is so expensive to use it as compared to misuse detection. Challenges in anomaly detection. The first challenge in anomaly detection is accurate representation of normal behavior of each user is very challenging. That means accurate representation of normal behavior of each user is very challenging. Anomaly detection must have to handle this challenge because for this actual anomaly detection is used accurate representation is for, for actual representation is want by user. That's why anomaly detection is used, and this is the main challenge by the anomaly detection. Second one is selection of the user or system or network features to the use for building the normal profile. Selection of user, system or network feature is also challenging for building the profile. Third one is the boundary between normal and outlier behavior is often not precise or exact. The exactness, the exact notion of an outlier is different for different application domain. And next is need to be adaptive or accommodate evaluating user or system behavior. User behavior may evolve over time or there may be sudden changes due to some requirements. Yes, user may have to evolve sometimes or sometimes sudden changes is necessary for some requirement. That's why user behavior evolves. System behavior could changes due to upgrade of OS or library or compile. System behavior also changes because sometimes suppose Windows is updated or Linux is updated, library packet is changed, the compiler or interpreter is changed. That's why system behavior is also changes. This is the also one of the most challenge in front of anomaly detection. And the last one is availability of labeled data for training and validation. This is also important because availability of labeled data. If data is not labeled, then also our detection system can't recognize the data. Means which data is needed for training or validity. That's why availability of labeled data is needed. Output of anomaly detection. The output produced by anomaly detection system are one of the following two types. The one is scores and second one is labels. The first one scores in that scoring technique assign an anomaly score to each instance in the test data depending on the degree to which that instances is considered an anomaly. And the second is labels. In the labels, techniques in this category assign a label normal or anomalies to each test instances. So this is the our slide presentation, PPT presentation on the anomaly detection. Thank you.
Hello everyone, this is Shivam Ranjwe and today we will see what is deep learning. So in this presentation we are going to see these following points. So first of all, introduction of deep learning. So what is deep learning? So deep learning is a branch of machine learning that uses data to teach computers how to do things that only humans were capable of before. So for example, how do machines solve the problem of perception? So what is perceptions? So perception is the ability to hear. So talking about the history, 1958, Frank Rosenblatt created the perceptron, an algorithm for pattern recognition. So in 1989, scientists were able to create algorithms that use deep neural networks. 2012, artificial pattern recognition algorithm achieve human level performance on certain tasks. So talking about the principle of deep learning. So deep learning is based on the concept of artificial neural networks or computational system that mimics the way human brain functions. So there are many technologies in deep learning. So we are going to see the major three. So first one is convolution neural network, that is CNN. Second one is recurrent neural network, that is RNN. And third one is long and short-term memory. So if you see the working of deep learning, so consider the following handwriting sequence. So you can read this 5041 and 92. So it's easy to read this, but it becomes difficult when somebody tells us to write a computer program to read this. So the idea of neural network is to develop a system which can learn from the large training examples. So computer can use these examples and use their algorithm to read this text. So what are the advantages of deep learning? Deep learning does feature extractions, so no need of engineering features, moving towards raw features, better optimizations, and it can be used for multitasking, and it has better architectures. So what are the challenges? So it needs a large data set, and because we need a large data set, training time is usually significant. So these are some real-time examples of deep learning. First one is automatic colorization of black and white image. So we can use it to colorize the black and white images to color. Second one is automatically adding sounds to silent movies. Then automatic machine translation, that will translate the language from one language to another language. Then object classification and detection in photographs. Then automatic handwriting generation, automatic text generation, automatic image caption generation, automatic game playing, and all. So what are the future scopes? So deep learning will speed search for extraterrestrial life, and for astronauts, next step on journey to space will be virtual. And with the help of deep learning, we can also measure water where it is not available. So finally, the conclusion of this presentation. So the possibilities of deep learning in future are infinite, and that is from driverless cars to robots and exploring the universe and whatnot if the coming architectures are creative enough. Thank you for watching.